Okay, this is probably going to be the last streamed one, at least, for a little bit. I get this probably a bit too early for some of the American people, but I just felt like doing it now. But I'm going to be going like home tomorrow, so it's really hard to stream then. Might do some just recorded videos, we'll see. Plus, UCycle is very close to this one, so I doubt I'm going to do it in this one, because there's some other rough ones in between that, but again, I guess we'll see. So last time we did BA. So we have safety square, color talk, double arrows, Boolean wires, and vectors. I'm going to do it in groups of 5 here because of how some of these are set out. Let's get started. Great, we've got 3 vectors on vectors. Okay, safety square. First, determine the type of fire present by going to the table according to the following conditions. So all the numbers on the square. So all the numbers on the square is less than 5 is 7. So it's more than 6. So all the numbers on the square are more than 6. Which is I should see. If there are more than 4 ports, no. If the sum of the numbers is greater than 9, no. If the other number is equal to 4, no. So number contains A, B, C, D, or K, it does. Plus A5 is present. And then the priority list, there is no special. So serial number that contains a vowel, no. So water. Water being that one. Water with red LED is white. Olive line D. No. 4 more batteries, no. DRJ, no. White, blue, yellow, yellow. Okay. This one's quite simple. O 1 dash B. Here the buttons with your position in the grid or 4 cardinal directions. So our starting position is 28, which is there. I should draw a new position. So I remember you can reset. Okay, so 28 with 8, 5, 2 and 7. So we can pretty much press any of these inner ones to get direction. So spool up is left. It's spool left. 4, 2, 4, 1. What about the double ones? We have 6, 8, 6, 7. So both would be have ambiguous cases, so let's just go all left. We get 4, so we went either up or down. So what could help us here? Or the double moves goes. So one of the double moves would get us between them. But then we would also have we have 4, 3, 6, 5, 3 and 5. So we have hit 5 when you were at this one. If we hit 5 or 3, we know we're on this one. If we hit 5, we know we're on this one. If we get 3, we still don't have any information. And if we hit 6 or 4, we know we were at the top one. So big up is to 4, which the only possibility there was this one. So up is big right, meaning that this one was small up. So let's go back to the small directions. About this because this is where we're going to end up in the end. So we only have right and down left to go here. And that gives us 5 or 7. So small right. We had that previously. Anyway, so this could have gone between them in the end. Forgot about that. So let's reset. Let's reset this setup. Right, we're at 63 this time. Where we have 1, 7, 5 or 6, which is fine. 6, so small up is small down. Then we have 9, 4, 5, and 8, so that's fine as well. Actually, we don't even have to care about the bottom one here. We have these three, 9, 9, 4, 5. So left is small up. Right is 2, so small left. So then small right. So it should take us back to here. But can we do stuff from here first? We would have 3, 7, 5, 1. So that would be cool. So big up gives us 3, which would be this one. So big up is big left. Then we have 2, 5, 9, and 2. Okay. Oh, we can't have left, so 2, 5, and 9. So that's fine. It's big left gives us 9. So big left is actually big down. So we only have up and right left. So right becomes 3, which would be up, big up. Then we can check by, so small down. Small down take us right, so this should give us 1. Yep. And then big right take us back to 63. Okay. It doesn't even know batteries in the bottom, yes. So since we have an even number of batteries, move to a position that is 1 higher than your current position. So those are the places we need to get to. So we need to go big left, then small up, then small right, then big down, then big right, then small left, big up, then small right, then big up, and then big left. I was going to misclick there. Okay, Boolean wires. Not D and G. In number of modules on the bottom. That's false. So true. Got true and true and true. True and true, so that's and. Okay. So only one pair variables on the bottom. True to false. False, false. False, false would be two falses would be true for not or. Okay. So this one was false. So we had true, true and false. True and false. That's true and false. So we can do XOR for that. PS2 port present false. So greater than unsolved. Yes. So greater than unsolved, yes. But not so false. Got two falses again. PS2 port present is false. Solved modules greater than unsolved modules is true to false, or false, false. So NOR again. And then if we have an on the bottom, false to true, false to true, true. So and again. False to true, yeah. And finally, vectors. So, auto vectors. The auto vectors on the graph. It will always be the shortest of vectors. It will always be the logic exists. Use the colours of the vectors to figure out the number rather than the nearest tenth. For the final calculation. Keep in mind so the shortest one is the orange one. Or rather, it will always be the shortest. So Thanks, Alex. Sorry, it says vector 1 would be the shortest one, but it's saying on here that vector is the longest one. So vector 1, its components is negative x and z, positive y. Vector 2 is negative y and z, but positive x. And the third one will be negative in x only. And then values being 71, 64, and 91. 78, 57, 9, and then 5, 88, 77. If more primary colours OIB appear in the vector segregated GPO, we've only got secondaries. More secondaries appear bases in primaries. Multiply the magnitudes together and divide over the first digit of the serial number. Multiply the magnitudes together, so that would be 32 times 97 times 117 divided by divide that by the first digit, the serial number, so 8. Multiply magnitude divide that by the first digit, the serial number, or the necessary number. Then add the sum, the x components and y components, plus minus 81 plus 78 plus minus 5 plus u4 minus 57 plus 88 minus 81 minus 9 plus 77. So we got our number currently on my calculator. I'm hoping it's the right number at least. I've never done this, done the 3 vectors before. Three colours. You have blue, white, red. Make sure that's the start of the loop. Yeah. You want to one vector is present. Otherwise, add together the necessary number derived from multiple vectors and the number of arrow modules that exist on the form. Which is none. So it will be called S. If each colour in the sequence, we apply the rule from the body list below, repeating the rule till the same colours appear right over one another. So blue, add the number of port plates and indicators on the bottom. So that is +4. With white, subtract 27. Red, add 122. You modify this. Go for the decimals. And modulate by every value multiplied by 15. So our final number we got was 187477. Mod 15 of 15, so 7 plus 1, 8. So hopefully this is right, but I doubt it. Okay, that's cool. Was not expecting to get that right. Okay, good start. Okay, up next we have a lot of cycles, as partial derivatives, and forget us not. So Caesar cycle, forget us not, forget us not. Affine cycle, Pigpen cycle. If I add these two onto it, then have 1, 2, 3, 4, 5. So let's add the other 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, okay. So we're gonna add on flag bunch of Playfair cycle. Here's nothing. So forget us not. We have 6 stages. So we in the order that we solve them in. So first stage would be partial derivatives. And let's see if I remember how to do this. So we have to calculate the values of x, y, and z for each one. Okay. So on stage 1 we have SN1, which is 11 plus unlit indicators, 11 with 13 to 3. So number 5 is 14, minus indicators 14 to 4. Barrier holders plus port plates is 0 plus 3, so 3. Was low 10, 3. Then 3, 7, minus port plates 4. 7 goes to 4. 4. Various plastic holders is 0, which results in 0. The value for that variable is 1. So number 6, 9, minus the indicators, nothing. So that would be 9 minus 0, 9, 9. Then all indicators with batteries, that's 2. So number 4 is 7. Yeah, so number 4 is 7 minus ports is 4. 7 goes to 4. And then serial number 2, 22. 22 plus 3 is 25. 5, I think. And then you make the LED primary colour and driver spinning variable. Otherwise, driver spinning variable is associated with the colour that is not component of the secondary colour. So we have orange, so we're deriving with to blue. Because green would be these two, and then red, purple would be those two. So deriving with respect to Z, the first term goes away. So deriving with respect to Z, we get nothing from the first term, so it just goes away. We get minus 7y and plus 4x cubed y cubed. Sure, this gives nothing. This just takes away Z. This also just takes away the Z. Okay, back blue again. So we're deriving with respect to x this time. So that goes away. That becomes 12. That becomes 2. Because deriving with respect to z gets rid of that. X gets rid of that. And then we have 12 and then 2 and then k. Then the value 1, 4, and 9 gives 192. Then we have yellow. So just in respect to x again. So I suppose 24. That becomes just x. So 2, 4, 5. 5, right? Yes. So hopefully. Okay. So stage 5. Stage 5 will be our next one, which is UCycle. Okay. So we did clockwise. But by the number 45 kilometers rotations, this is shifted forwards, I think it means. Or backward. Or we have to shift it backwards, I think. So our letters we have are Z, L, E, P, S, M, W, F. And that's 1, 2, 3, 4. 1, 2, 3. 2, 7. Yeah, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4. 3, and so on. Go backwards then. 26 minus 4. V. 12 minus 3. I. That's C. 16 minus 7 is 9. N. That is 9 as well. So is it vicinity? 6 minus 7 plus 26. Yeah, vicinity. I did the whole word there just to make sure I definitely had the right numbers. So then we're going to take the response word, which is triangle. And re-encrypt it. So So 24, that's X, TUVWX, RSTU, IJK, BCDEFGH, OPQRS, HIJK, MNO, FGHIJKL. Just go check. UVWX, STU, JK, BCDEFGH, OPQRS, HIJK, MNO, FGHIJKL. Okay. So our next one will be stage 4, which is Affine cycle. Division is multiplied by 2n plus 1. Number n for each dial over 45-degree clockwise rotations. So we have SELLORA. Is that O or D? It's O. But it seems though, actually, a lot of these lists are already correct because we have 1, 2, 3, 0, 0, 0, 1, 1, 0, 1, 2, 3, or 5. So we have I think that's how it works. Yeah, because it's multiplied by 1. So 19 these are all encrypted, right? So we had to find the letter that becomes it. But I feel like we can figure out what our word is already. So yielders, let's just double check. So 25 times 2, 3 plus 1, then minus 26. We get S, yes. Then we have 4 times 2 plus 1 is 3, which gives L. 5 times 3 is 15, which is O, yes. Then we have 19 times 11 minus 26 minus 26, which should give us 1, yes. So yielders is our word. And going by the other way should be simple enough, because we're now doing the actual encryption part, which I think is easier. So 23 times 2, 3 plus 1, then minus 26. That's E. Then we have HAT. Then we have 19 times 2, 1 plus 1. That's E again. We then have I, multiplied by the same thing, which gives us A. Check. 9 times 9 times 3, yeah, 27. Then we have T, and then 19, 2, 5 plus 1. A. That's a weird answer. Okay, now next we have stage 2, which is Pigpen cycle, yeah. Remember, this is one of the ones I've never really understood, so I guess here goes nothing. You interested in Pigpen cycle below. From north, Pigpen characteristic to face direction that is pointing. Okay, so we have HK, ND, UKNN. So, which interface direction that is pointing. Okay, so So K, I'm trying to find a letter that only appears once in the grid. U, if U is pointing downwards, to give U, that would mean that we have S, I think. This one stays the same, I think. The H pointing down left and it's giving us down right, meaning actually I think that would be P actually, because if it's U and it's pointing down we need to flip it 180, so first T. The H we need to go 180 and then once. So there's a chance that both the H and H might be the same. So we would have to go 180 then once more. So M. K to be pointing that way. So we need to go counterclockwise. So O. Is it kind of looking like a word? G to be pointing. We need to rotate it 180 and then go back the other way. So goes to F and then go once back the other way. So going clockwise. Yeah, okay. Is there one that monitors? No, but we have monotone. Let's just try that one again then. So D pointing like that means we would have to go 1, 2, 3. There we go. We have N, which just N. No, it's swapped between N and E, yeah? Okay. So monotone becomes quitters. And then applying the same encryption. Okay. So Q, we need to rotate around 180 clockwise, then one more. That'll be that, till we get to there, and then one more. Get to F. This is the first one I'm expecting to get strike on. K. We go to M. Okay, yeah. Right, we're not doing K, we're doing U. So U become S, I think. U become that. Maybe we can get that one the same. U become that, that, and that. We're going counterclockwise twice. Because it's to that, then that, yeah. Excuse me. Right. T. We're going clockwise 1, 2, 3. 1, 2, 3. Yeah, okay. T again. Flipping it completely round. We have E going so that would keep the orientation the same. So that will stay as E. R, we're just going 1, 2. P, and then S, we're going 180, an extra 1, so G. We become that, that. Wait. We become that, that, that. 4, 5, yeah. Then I can double check quickly. That'll be 1, 2, 3, yep. Wait. Yeah. That will be. That'll be 1, 2. No. That'll be 1, 2. I say it's the same. T becomes. T goes 1, 2, 3, and then 4. E just swaps between them. R is just 1, 2. S is same as 1, 2, 3. Okay. There's 6. Flower patch, I think. Yeah. Meaning stage 3 is going to be Playfair cycle. With flower patch, we have green and yellow. Green and yellow is V. That's a violet. Okay. Then Playfair cycle. Okay, so it's simply 2-degree rotations this time. So we have 1, 2, 3, 4. 1, 1, 0, 0, 1, 4, 0. And then these are base 5 numbers. So we have 4, 5 plus 1. That's 21. Plus 1 is V. That's just 5. So F. That's 1, so B. And that would be 20, so U. There's each pair. So you then have the in-between ones. The first 7 letters. Yeah, it's the first 7, so you then have these ones. So 1 and 1, 6 and 7, which is G. 0 and 0 is 0, which is A. And 1 and 4, B. 1, 5 plus 4 is 9, which is J. Running A lens with the rest. So this is very different to Playfair Cipher, which I did previously, because the omitted letter this time is X rather than J. V, G, F, A, B, J, U. Then grid. LK. So it's usually one to the right, but we're decrypting. So we're going to be shifting that back along. So Ki, IQ becomes LO, AZ becomes BY, ZU becomes TE, kilobyte. Kilobyte becomes bullhorn. If I contains the same letter twice, it gets changed to a Z. If I contains the same letter twice, it gets changed to a Z, yeah. And then encrypting using this, we get BU becomes GE, LZ becomes MY, HO becomes IN, and RN to row just wants to write, so N O. GEMYINNO. Okay. Then we have so let's find it for these. Partial derivatives 716. Pigpen, Cycle, these 252. Playfair, Cycle, Affine Cycle, UCycle, Flower Patcher. Right, okay. You need to work on the bomb to determine which Affine conditions placing your scale is not. If your serial number contains 4 letters and 2 numbers, yes. Subtract the number of batteries on the bomb from the first digit. Subtract the number of batteries on the bomb, so none. Subtract the number of batteries on the bomb, none. The first digit is a 3-digit number, so we're just going to take the first digit. So we have the value, so in this case it would be 7 for example, 7 plus the absolute value, so the least significant digit from the most significant digit. Least significant from most significant. Which is 1 minus 6. So 2. Okay. 2, 5, 2. 2, 5, 3. 2, 5, 1. 2, 5, 0. 2, 8, 0. Okay. Okay. So this is where the order gets slightly thrown because we of course have organisation this time. With forget perspective, alphabets, jack attack. And yes, we could be doing FP the normal way. Unless I struggle, then I will do it the cheaty way. But sure, this is going to be a very small FP and organisation, but that's just how I ended up setting it out. So, and given that one of the words we had to do is Jumble cycle. Okay, so we're starting with alphabets. Okay, so we have the same logic gates but in a slightly different order. So we get bin 19 plus 9, 11100, 1111. There, and then okay, so this is 110 in 302. That'd be 11. What gives us 111? 01. Gives us, that's 11 again. 011 is 10, and then 10. And then that will become and then since that's greater than 9 minus 9 from that, you get n. Just check. Yep. And then s. Which we can check again. Okay, then we have this is 010, 20 plus 9, which is 11101, and then 7, which is 0011. We're going to slightly different order this time. So 0, 1, 0 is 0, 0. 0, 0. 0, 0, 1, or 0, 1, 1 even, is 1, 1. 101 is 1, 0. 0, 1, 1 is 1, 1. That becomes 7. That becomes 5. That's 4 plus 2. 4 plus 2 plus 1 is 7. And 4 plus 1 is 5. Before we do that, because we need to note down stages. Stage 1. The first stage is starting time, so it's 300. We have magenta. Magenta, yellow, red, green, orange, blue. Then we have we have 294. Then we have red, yellow, blue, orange, magenta, green. We have Jack Attack now. It's a Unicode. Is this an optimized manual? Yes. So to try and do this on memory then. Traffic jam, that's gridlock. I'll go up. Friendship. Poetic, Kudasadoku. Multi-dimensional hypercube. Okay. That was at 293. We got red, yellow, green, blue, magenta, orange. Now a jumble cycle. Okay. So over the Playfair. Before I write communication across all dials, starting from the octal number. It's basically the decimal frequencies as much as 26 are calculated. Okay, so the rotations we have is 0, 3, 4, 5, 5, 4, 7, 3. Okay, so for octal, 0, 3 is 3, plus 1 is like D. So it's going to be this mod 26 plus 1. Okay, so 3, 4 becomes C. 4, 5 is L. 5, 5 is T. 5, 4 is S. 4, 7 and 3. H. Okay. Okay, so A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, Y, Z. D, C, L, T, S, N, H. And we use that to decrypt the cyan labels, I and H, which gives us GNA. But there's Caesar, 1, 2, 3, 4. So T. We dodge using the affines currently. So that becomes O. Then 1, 2, 3. Gatepost. 5 times 2 and 5 times 11 gives you 5. Gives us the C, which is on there, okay. And the same again, but with P, which is 16, 2, 5 plus 1 minus 26 until we get T, which is on there, okay. Just make sure 19, 2, 7 plus 1 going down, be a Y, yeah. Okay, gatepost. Yeah, oddness. Get this W and H WH becomes VA. A shifted forwards by 4. B, C, D, E. Then we have, so we're marking these off. If C's are affine, Pigpen, affine, Pigpen. So 20 to 5 plus 1 gives us L. 14 to 5 plus 1 gives us X. We have the Pigpen E, which is in the middle again, so going 180 wouldn't change it. We then have 19 to 7 plus 1 is just what we had before, yeah. And then S is there, it's there, it's there. Let's make sure. $20 times 11 minus 26. Then 14. I have a TC here. So 20 times 11. Then we have 14 times 11. And then 19 times 15. Then I'm pretty confident on the Pigpen letters as well. One, two. Alright, here goes nothing. Nope. Okay. And now, you know what to do with these. Do the following table and some in the face. How many minutes you got? If the number of minutes you got on stage on is divided by 6, 300 is divided by 6. I think so is next one down. Yeah, so we got MR and then 293. How many you got on stage prime? is prime. Yes. Face 2. Y. I didn't even realise the Y was the second base in all of them. Okay. Next, use the CubeNet that corresponds to the starting face's colour as the CubeNet for that stage. Look at the starting face you've got. Is 1, 6, look at the cube, so 4. So 4 will be the top face. Okay, so that is. Apply the cube. Apply the CubeNet you've got to the cube starting from the face you've got. Your number 1 on the CubeNet. That would be M. Then 2, 3, 4. The G. And 6 would have been the next one from there. So this one. 4. With 5. What faces do we not have yet? The front 2. Yeah. Okay, so yeah. So number 6 would be number 2. And we're not expecting to get this right at all. And we had base 1 again. Red. So red. Going up and left, so number 1. The 1, 2. The 1, 2, 3. The 3. The B. 4th one is the one above, which would have been 1, 2, 3, 4. So the 4th one that I got anyway. the bottom face would have been 6, which is G. This one is over 5. Number 5 and number 2. We run like that. Yeah, okay. And then we had face 2. So we're now viewing it from here. So we have Y. Then we get that one. So that's the 5th colour. And 4 is going to be the top one, which is R. Going up from there. 1, 2, 3, 4. So 4th colour. So 1, 4, 2, 6, 5. Down. So that's there actually. Be 1, 4, 2, 6, 5. And then that'll make. So I think that's what we have. You check the shift rules, shift less you got. The rule be the number of batteries. Okay. The rule will be the number of batteries multiplied by the number of ports. 1. Batteries multiplied by ports, which is 1, yeah. So 1. So we're adding X. X will be numerical value to the last letter of the serial number, which is 23. X will be the numerical value to the last letter of the serial number, 23. We're adding 23. So that. At least 3 vowels. No. Last letter is a vowel. Not true for any of them. There are at least 2 const. At least 2 consecutive vowels in the sequence. There are at least 3 consecutive consonants in the sequence. There are at least three consecutive consonants in a row. The fourth letter. All of them, I think. So, yellow. Okay. Okay. So we're now up to the next interesting one. Let's have a look. Okay. We go for an hour and a half. It's a decently. I've been going for a decently short while. Do I want to do this today? Well, since I'm not going to be doing this for a little bit after today, at least live, and let's see how it goes. Okay. ZKOFITWN. This is scheduled from left to right, so we'll be doing it from right to left then. So we're starting decrypting first with Southwest. One of our basic substitution cipher. Position of the dial corresponding to which of the 8 words in the list below is a keyword from this cipher. 1, 2, 3, 4, 5, 6, 7. Okay. So we're using this one. Clearly is unlit. Maintaining unlit alphabetical order. Those remaining 13 letters written in reverse alphabetical order. So V U T S R Q P O N M L K J I H G F D E E D C B A. Okay, yeah. Then unpredictable. There's an even number of batteries. Yes. The keyboard precedes the remaining lessons to cipher alphabet. Yes. That is this. Why is this one too long? A doubled up letter somewhere. Yes. And then each letter of the alphabet is mapped onto the letter of the alphabet with the position. So since we're decrypting, we're going up the other way. So Z becomes N, K becomes B, O, T, F, Z, I, G, T, I, W, P, N, B. We then have southeast, Pigpen, okay. It's translated using two Pigpen targets below, from north. Anyway, we're going the other way. So south. Okay. Do you think there's a list on 0? This time for the list both position 0. The two lists give keywords, one from list A, one from list B. If the numbers in the serial number add up to more than 9, no. The keyword in list B given by position of the dial, 7. One, two, three, 4, 5, 6, 7. Keyword in list A, the keyword in list A is given by number 45 rotation style from the previous dial, which is 1. Zero, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Yeah. 0, 1, 2, 3, 4, 5, 6. And then 0, 1. Those are used to construct two cipher alphabets, where each keyword precedes the remaining 16 letters. Okay. So true trapezoids. For each letter, from left to right, intersect namely below the dial in its position. It does the LED, well, if the south dial is the same, the second cipher alphabet is shifted to the left. Where's the first cipher alphabet? These alphabets are not reset these letters become encrypted, so it adds on to itself. So the first one, it's not the same, so the first cipher alphabet is shifted to the left by number 45-degree rotation from north, so 2. Actually, I think in this case we're going to have to do it total. Do it from the end to the start. So that would be going from this. So I think we can do this, but then go from the bottom to the top one. So N, Q, and same cells, so one, two, three. Then Q. We then have same again, so 1, 2, 3, 4, 5, 6, 7. Same, but it's different, but with 0. So R is different again. So we're doing the first cipher alphabet as we 1 is Y, and then E is definitely as the dial. So that'll be, I think it counts for that letter as well. It's Well, could you let this in the second? This is in the second alphabet. So it's like alphabet. Right, I think we're doing it right. So P, and then same. So 1, 2, 3, 4, 5. Okay. So northeast. Caesar. Here corresponding to this die, use the instruction followed by the die corresponding to this. Sweet. Each letter is introduced during the alphabet by the number of 45 degree clockwise rotations. So from north, the direction is pointing. If corresponding to this die is lit, which it isn't, otherwise each letter is shift backwards through the alphabet by the position of the die corresponding to the cipher. So and then shift it forwards by their position of this dial, so 1, 2, 3, 4, 5, 6. So shift it forward by 6. Then shift each one backwards by the rotation, so minus 2 y, minus 3 x, minus 7 is L, minus 0 is that, minus 1, minus 1, minus 1, minus 1, 1, 2, 3, 4. So R, and then 1 minus 5 plus 26 is V. And then we're doing the same again. In this case, now shifting forwards by 5. and then backwards by it again, so -2, -3, -7, nothing, -1, -1, -4, -5, yeah, really the same thing again. I guess so, yeah. Okay, then we have north. If number 4 relations down from north is odd, the base given both sides is 1. Okay, so 0, 1, 1, 0, 1, 1, 0, 1. On 4 pairs of bits by grouping the bits corresponding to adjacent pairs from left to right. That would be left to right in reading order. So we have okay. Each of the 8 pairs of bits corresponds to each of the 8 tiles from left to right. In the operator corresponding to the position of the north pointing dial 4 for this. And the truth values each pair it depends on whether each is true or false. It implies so it implies in this. Yes. So you have returns false when the left input is true and right input is false. With true, false, true, 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 false, false, true. So the true letters PLG below 0.0 is lit applies to the output of logic cipher. But since we're decrypting it, we're going to look at it in this row and find out what letter it was beforehand. That would become F, M, H, K, and G, and then the false ones we have X, N, S, A, and B. We have northwest, find the 3D binary representations of rotation start from north for each of the dials. So four, 1, 2, 3, 4, 5. If you go back to the dial, it's lit, all the zeros and ones with zeros. So zero, 0, 1, 0, 0. Combine all of the binary representations together from left to right. Make 0 and dependent 1. Both representations through prepend to 0, append to 1. Everybody having two sets. So whether each exactly position and string of bits is 0, 1. So meaning is 0 set being A, B, D, F, G, H, I, J, K, L, M, N, O. Q, R, T, W, Y. And then one will of course be the rest of them. So I'm going to do like this. Then So each letter is lit, so each letter in the word is shifted to the right by the north dial. But in this case, we're going to be shifting to the left. So the northwest dial is 3. 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. The southeast. Yeah, now we have southeast. So we use over 2 because it's lit. You don't try to use the. Okay, so A. So we're de-rotating it. So going there and there. S is going to be 1, 2, 3. Okay. J is going to be we're going that way 7 times, and we just go clockwise once again. So I, then that stays as it is. Then once counter G, B, then basically 180, D, and then three clockwise. 1, 2, 3. Now we have east, Playfair cipher. Well, if the last dial is pointing east, then number 5 degree rotation starting from north. The next dial corresponds to which was in the list. There's less than 3 unique ports now. So people from list B, the next dial, 3 from list, a third from list B, so we're getting to the moment of truth now. if this doesn't end up giving me a giving me anything in the end. Okay. The word is entered. It's in reading order. So it's giving X. I'm not expecting this to be right. What is saying that each letter is two of the letter directly opposite in the P square. ID. Yeah, I don't think I've done this right. That would be double F. Oh. Yeah, I've not done this right. I see where I messed up. Okay, there's one mistake. Okay, so I was just completely wrong there. Yeah, this one's going to be rough. I'm going to leave it there for now. This might be a slight worry because I don't really want to get that wrong again. Guess we'll see after I've had the break what happens here, but I'm worried that this might be a sticking point for a little bit and might end up causing me to choose to skip it. I guess we'll see on the next one. But until then, I'll see you later.